Hello and welcome to a video that will hopefully refresh your memory on shapes, angles, and all things related to MCA review. I would encourage you to have your notebook out. I would encourage you to take notes as you move through the slides. Pause them as you see fit. Write down what you would like to write down, and then continue on with the slides when you are done. The first place we're going to start is reviewing all of the different types of angles that you can see. You can see on the left is the list of names of all of the angles that we're going to talk about on this slide. The right-hand side has a picture of some popsicle sticks with the angles drawn inside of the popsicle sticks or around them. What I would encourage you to do is to pause the video after each description, maybe copy it down into your notebook or take a screenshot and save it right to your Notability, whatever you would like to do. Let's get started with the right angle, the purple popsicle sticks. As you can see, the right angles come together at a direct up and down point. They form a 90-degree angle when they meet. This is important because some of our shapes moving forward in this slideshow, we'll talk about the right angle. So the right angle has a 90-degree angle inside of it. The acute angle is the one that we'll talk about next. The acute angle is an angle that forms when two lines meet and the angle itself is less than 90 degrees. So you can see from the picture that the angle itself inside right here is less than 90 degrees. Moving on, let's take a look at the obtuse angle. The obtuse angle is considered a large angle because, as you can see, it's moving past the 90-degree angle to something larger than that. So the angle itself would be greater than 90 degrees. So anything 91 and above. The straight angle is next. That's the red one, the one way down here. A straight angle is something that just goes straight across. So there would be an angle here if you could picture this maybe moving up to form an obtuse and then a 90 and then an acute angle, but it does find itself straight across. So this one is equal to 180 degrees. It is a straight line. And then the reflux angle is not something that we typically talk about, but it's super important as you move forward in geometry. It's the angle that's formed outside. Do you see how I just highlighted that in yellow? It's outside. So it's the outside angle that's formed after an acute angle. So it's anything from 180 degrees to 360. 360 is all the way around. That's a full circle all the way around. And then the 180 degrees would be from the straight line moving back. So the reflux angle is an angle that is between 180 degrees and 360. Just have to fix that. 180 degrees, including 360. So pause this video, write down what you need, and I'll meet you on the next slide. The next thing we want to talk about is the way that multiple lines will come together and form different structures. So for each one of these, we're going to talk about what the line actually forms and how it relates to different geometric shapes. The first one we'll talk about is the full rotation. I just talked about that a few minutes ago. If you go all the way around from one end to the other, you rotate completely, forming a circle, as you can see, and that is a 360-degree angle. So 360 degrees. Next up is this idea of the perpendicular angle. Now, we just talked about that a few minutes ago. This perpendicular angle forms a 90-degree angle, and it's when two lines completely meet, and right there at that point, they meet at that 90-degree angle. So a perpendicular angle looks like this. They are two perpendicular lines, and together they form a 90-degree angle. Our parallel, that is our skiing. We don't want to cross over. Parallel lines never cross. And we typically write them like that. Intersecting lines will be what we talk about next, or these purple ones down here. They intersect at a point right there. As you move into math further on, you'll talk about that intersecting point being the point of intersection. and you'll spend a lot of time solving equations and finding that point of intersection. So intersecting lines are two or more, and they intersect at a point right there. Vertical lines, let's have a conversation about those. Vertical lines we see a lot. They go straight up and down. A vertical line is the y-axis. Yay. We all know that, right? And then last but certainly not least is our idea of the horizontal axis, and that would be our x-axis. So again, I would encourage you to make sure you have these written down or you know these, and pause the video. I'll meet you on the next slide. Now let's take everything that we've learned and let's put it together and have a conversation about the different types of shapes. We will start with our quads. Quads are shapes that have four sides. The word quad means four. Our two beginners are the square and the rectangle. They are kind of our big deals when it comes to shapes. You see them all of the time. The square has four sides that are the same length. The square also has four angles that are formed when two lines meet perpendicularly, forming a 90-degree angle. The area of a square is going to be the length times the width. If this would be the width and this is the length, this would be the width and this would be the length. And then the perimeter of the square would be the length plus the width plus the width. You could simplify that to be 2L plus 2W using those great skills of algebra that you've developed over the last few weeks. Let's move into the idea of the rectangle. The rectangle, very much like the square, has perpendicular lines that meet at 90 degrees all the way around. They have two pairs of sides that have the same length. As you can see, I am adding a hashtag on the up and the down to show that they're the same, similar in length as the ones on either side. If we say that this is the width and this is the length, the area is exactly the same. The area would be the length times the width, and then the perimeter would again be 2L plus 2W. Next, we're going to talk about two more quadrilaterals, the rhombus and the parallelogram. You can see both of these are leaning to the right. So the rhombus started out as a square, and now it is being kind of swished over to the right. So the rhombus itself has four equal sides. But what distinguishes the rhombus from the square is that the lines do not meet in a perpendicular fashion. As you can see, we have opposing angles that would be the same. So those two angles would be the same. And then these two angles would be the same also. I did fail to mention this in the last video for the last slide, but the sum of the angles inside, the sum of the angles of a quadrilateral is equal to 360 degrees. Why is that? Let's go back to the rectangle. If we understand that the rectangle has four angles that are each 90 degrees, 4 times 90 would be 360. And that would be the same thing for the square. So the rhombus still has a sum of angles that is 360 degrees, but none of them would be right angles. I hope that you can notice if I highlight this one and this one versus blues on the opposite side, I'm hoping that you can tell just by looking that the blue angles are both obtuse angles, whereas the pink the pink angles are actually acute angles. So you have pairs of acute angles that are the same and pairs of obtuse angles that are the same in the rhombus. Moving on to the parallelogram. The parallelogram also started out as a regular four-sided shape, which was a rectangle, and then again it was squished over to the side. The thing about the parallelogram is it has to follow suit with the rectangle, meaning that you have sides this way that are parallel, and then you have sides this way that are parallel. These arrows that I just drew indicate parallel lines. So we have lines that form that go straight up to the sky this way that are parallel in the parallelogram. This also works the same way in the rhombus, but I'm just going to do it for this one since it's larger. So those lines, the blue lines, are parallel. The green lines are also parallel. We have a sum of internal angles, so the sum of the angles is equal to 360 degrees, just like it was in the rhombus, the rectangle, and the square. We also have parallel angles that equal each other. So these angles and these angles are the same, and these angles and these angles are the same. So opposing angles are the same. I will color them just like I did for the rhombus so that you can see a little bit better. The next thing I want to talk about is the idea of finding the perimeter. So the perimeter for both of these, the perimeter is going to be the sum of the sides, right? Because that is the definition of all perimeters. I want to not focus on the area of the rhombus. That's not something that's going to come up for you at this point. But I want to focus on the area of the parallelogram. So when we talk about the area of the parallelogram, we want to talk about the height times the base. So the words are a little bit different. So what do we mean by that? This bottom line right here is called the base. And then the height is the line that is drawn from one corner point to the bottom. This is called the height. So you would take the height times the base, and that would give you the area of the parallelogram. Again, pause this video, write down what you want, and continue when you're ready. We are going to skip the diamond slide for now. Doesn't seem as if there's going to be a lot of diamonds on our MCA test, so we will skip this one. All right, let's have a conversation about the trapezoid, the oddly shaped quadrilateral. So the trapezoid is in a category all by itself. As you can see, there are parallel lines on the top and on the bottom. If we take a look now at the lines on the side, these lines over here and this line over here, hopefully you can see that they are not parallel. They are actually going up in different directions. They will eventually, if they went on forever and continue to go up, they would eventually cross at some point in time. So we're not going to have a conversation about the interior angles being the same as you crisscross, because that is not a thing in the trapezoid. We will talk about the fact that the measure of the interior angles, so the inside angles, just like any other quadrilateral, equal a sum of 360 degrees, just like all of our four-sided figures. So that is definitely a thing. What I want to talk about actually right now is finding the area of our trapezoid. So the area of the trapezoid has a unique formula. It is A plus B divided by 2, and then you take all of that once you have finished that and you multiply that by h, the height. So what does that mean? Well, just like in the parallelogram, when you drop straight down from the corner to the base and cause it to be a perpendicular line making a 90-degree angle, just like we did before, that is what we refer to as the height of the trapezoid. The smaller of the two parallel sides is A, and the larger of the parallel sides is B. So you would take the measure of A times B, divide that in half, and then you would multiply that result by the height. Next up, triangles. The right triangle, our famous right triangle. The right triangle is so special. We love the right triangle. You will spend a lot of time with the Pythagorean theorem in 8th grade math talking about the special right triangle. A few things to note about the right triangle. It is two actual perpendicular lines that are hitting each other. Here is one, and here is another. They are the legs of the triangle. They will come together and they will make a right angle right here. This is a 90-degree right angle, causing this to be a right triangle. What you need to know for your MCAs is you need to know the area of a triangle. So the area of the triangle is the base times the height, and you take that and you divide that result by 2. You take half. If you think about the triangle as being half of a square, half of a rectangle, the area of a rectangle or a square is base times height, so you're taking half of that. So the base is right here, and the height is right there. So you would take 1/2 of the base times the height to get the area of the triangle. Now, if we have a rectangle, and the rectangle or a square has 4 angles, and the sum of those angles is 360 degrees, and I said that a triangle is going to be half of that, so here's our triangle right in half. It should make sense that to find out the sum of the interior angles of a triangle, you would take 360 and you would want to divide that by 2, which is going to give you 180 degrees. So the sum of the angles inside a triangle, any triangle, is equal to 180 degrees. The equilateral triangle. The definition for an equilateral triangle is right in its name. An equilateral triangle has 3 sides that are equal. This one, and this one. They are all equal in length. They also have 3 angles that are all equal, which is kind of fun. So if we take this idea a little bit further, and we know that the sum of the measure of the interior angles of a triangle is 180 degrees, and we know we have 3 angles and they all have to be exactly the same, that means that the measure of every angle inside an equilateral triangle is equal to 60 degrees. So just a little fun fact. So here is the scalene triangle, only this is not a scalene triangle. A scalene triangle has 3 sides, obviously because it is a triangle, but 3 sides of unequal length. And what did I draw here? Not a triangle that has 3 sides of unequal length. So I am sorry about that. So what I want you to do is we're going to just forget about this lovely drawing here. And we'll draw another one. So if I had a scalene triangle that maybe looked like this, and maybe I can make that side a little longer so that it actually looks like they're unequal. We'll leave it at that. I would have this side, and that side. So a scalene triangle has 3 sides of unequal length. The interior angles still measure up to 180 degrees. Sorry about that. And now we have come to our last page. Yay. Let's talk about the 2 last triangles I want to just mention briefly, an acute triangle and an obtuse triangle. So we'll start with the obtuse triangle. The obtuse triangle is the big one, the big triangle. And why is it obtuse? Because it has one angle, the pink one. Angle is actually bigger than 90 degrees. So the angle, the pink angle, is greater than 90 degrees, and you can only have one of those. Now let's talk about our little acute triangle, our tiny little acute triangle. The acute triangle has 3 angles, obviously because they all have 3 angles, but all 3 of them are less than 90 degrees. So there we go. That is all the information that hopefully you need to refresh your brain on all of our shapes, all of our angles, and all of our measurements. I hope you enjoyed this and got some good notes.